Welcome to Computer Programming Lecture 5. My name is Mohammad Fasi and I will be your instructor for today's session. Let's see an overview of what we're going to cover today. First of all, we will see how increment and decrement works in C or in any language. Just general overview of increment, decrement, how they work. Then we'll see number systems, how many bases are there, how computer works and understand words and letters. Then we'll see some basic conversions of different number bases, how we convert from binary to decimal, decimal to binary, and so on. Then we'll see some basic mathematical operations on binary like addition, subtraction, division, etc. Then we'll wrap up our session with data models, types of data models, and there's a little case scenario, a little practice. We'll solve that. Okay. So increment and decrement. What is increment? I'm sure you guys are pretty familiar with concept variables. A variable is something that contains a value. It has a type. Let's suppose we have this counter variable. Yeah. We want to increment its value by 1. Okay. Increment basically increases the value by 1. So any variable, we have some value in it and we want to increment its value. So this is the sign. We write the variable name and then we write the sign. Okay, what it will do, it will take the value of this variable and increase it by 1 and again store the incremented value in the same variable. Okay, it will not generate an extra variable or so. Well, this is very useful in loops. For example, we're printing some counting or some pattern. So we can just print this counter and we increment it. We don't have to write it like this. Okay. Basically, behind the scenes, it is working as this. Okay. What it do? It takes a counter variable, adds 1 to it, and then stores the incremented value in the same variable. Decrement works the pretty much same, but it decreases the value by 1. Do you guys got it?
Yes, sir.
Yes, sir.
Okay.
Sir, instead of increasing by 1, can we increase by 2 or 3 or any other number?
No. If we're increasing by this sign, the plus plus, that is the increment operator, then we cannot increase it by 2. But if we want to do it manually, we can do that here. We write it like this, and here we have 1. Instead of 1, we can write any number, so it will increment it like this. Okay, but with this operator, we cannot increment like 2 or 3 or any pattern. Of course, we can write it like 2 to 3 times this whole. We can write this statement 2 to 3 times, and every time we write it, it will increment it by 1. So we can achieve that, but at one point, it will increment only 1.
Okay, sir, understood. So plus plus is basically increment by 1, but if you're writing counter only 1 plus, then we can increase by any other number.
Yes, of course. And the same works with the decrement, but it decreases the value by 1.
Yes, sir.
You guys got the concept, right?
Answer in the decrement, for the decrement, the negative sign. Should we
Yes.
write only once the negative sign, or like the addition, we need to write two times the subtraction sign?
Two times. Yeah. See, there are 2. And I mean, this is minus, and there's like a little space here. we should not put space if we're writing this. If we look closely, like these are 2 signs, not 1.
Yes, sir. Got it. Thank you.
Okay. Now in increment decrement, we have postfix and prefix. Well, they look pretty much the same, but their working is not the same. Okay, look here. Notice the sign here is before the variable, and in the postfix, the sign is after the variable. This is the visual difference, you can say, but in the working, it doesn't. It has different application. Now look here. If we using prefix, okay. Here, let's suppose we have an equation variable, and we're storing the counter variable in it. Now, how it is working? Let's see the result first. See, this is as expected. The counter value is being incremented, and its value is being stored in equation. But the main difference here is if we're using prefix, it will increment the value first, and then it will use its value. See, it is incrementing its value and then storing the incremented value into another variable. Now, this is not the case with postfix. Okay, this is storing the value first and then incrementing the value. See the result here. Now, if we're storing the counter variable in the equation, but when we see the results, the equation is still 0, but the counter is 1. If you guys understood the working, you should also understand how this worked. Did you guys got it, or should I explain it again?
Sir, I didn't get it.
Okay, we'll see that in working. Okay. We have, let's suppose we have a variable a, which whose initial value is 0. And we have a counter variable whose initial value is also 0. Okay. Now, if we're incrementing it and storing it into a, okay, when we print its value, you guys understand the basic syntax of C, right? Or should I have to explain this as well?
No, sir, we don't know the basics.
Okay. Okay, here we have value of a is equal to this, and value of counter. Okay, see here, we store the value in a, but still the value of a is 0. Now what happened here? We're using the postfix. Okay, it stores the value of counter first, and then it increments the value. Now, if we just change it to prefix and run it again, now see here, value of a is also 1 and counter is also 1. So more explanation needed, or you guys got it?
Sir, what if we like just change the integer? Can you
Yeah.
give any other example other than 0 so that I'll be able to get
Okay, okay,
what
okay,
we are trying
okay,
to
okay,
do?
okay. Here we have 1. Okay, a is 1. Uh, any value you want me to change it to?
No, sir, 1 is fine.
1. Okay, the counter is initially 0, but here we are incrementing the counter, so counter will become 1 and its value will be stored in a. Okay, okay, we are using prefix. You see here, a was initially 1, but it should be like okay, we stored counter in a, so it should be 0. But what happened here? We're using prefix, so it incremented its value first and then stored it. Okay, now if I do this and run it again, you see that uh, a was 1, so it should print a is equal to 1 here. But what happened here? It took the value of counter stored it into A and then incremented the counter. As you can see
Yes,
in
sir.
the end result, its printing counter is equal to 1. Now this is a basic difference in prefix and postfix. For example, if we are writing a long equation like 2 plus something, uh, we're solving a math problem or something. Now this is what you guys should see for. Okay, you should be very careful uh, for using postfix or prefix. Okay, because their whole value depends on it.
Yes, sir. Thank you very much. I understand.
Okay. Let's go to number system. Okay, you guys got the increment, decrement. Uh, let's move on to number systems. Now, what are number systems? We formally know decimal, binary, hexadecimal, but why do we need them? Okay, in normal life, how do we communicate? We communicate by letters and words. We Even if we are communicating online in written form, we write applications, letters, and so on. So they are written in like alphabets and numbers, but computer do not understand letters and words. It only understand numbers. So, but here we see alphabets are written on the screen. How it is showing this on screen? Well, it is not understanding this. Uh, every letter we type or store in the computer, it gets converted into numbers. Now, to understand that numbers, we should understand the binary and hexadecimal system to understand how it works with letters and other numbers. Okay, the letters and numbers are not directly stored into the computer memory. They get converted into binary or depends on the system type. Uh, it could be hexadecimal or decimal. So those numbers are get stored. Okay, computer architecture supports binary, octal, decimal, and hexadecimal, and so on. We will see binary, octal, decimal, and hexadecimal. Yeah. Now in decimal number systems, we have 10 digits from 0 to 9. Okay. We cannot exceed from 9. There's no logical number next. I mean, we have to add 1 before this 0, and we have to start over. Okay, we'll see that in a moment. In binary numbers, we have only two digits, 0 and 1. Octal number, we have 8 from 0 to up 7. Now, here is the main difference. Okay, hexadecimal, we have first 10 letters like decimal, but after 9, we we have A, B, C, D up to F. Okay, this is these are the digits that are available in hexadecimal number systems. Now, as programmers, we should always find the patterns to implement some logic here. So here see the pattern, 0, 1, 2, 3, 4, and up to 9. And then we start back from 0 again. Okay, this series will repeat itself over and over again. But how we tell that a number is has increased or not? We see this one. Okay, this is being added on the left side of the initial series. Okay, uh, 0, 1, 2, and then we have this one. Now, notice there is a pattern. Every time this 0, this series ends, we add 1 to the left side. Now, if we reach 19, what will it become? 20. Series starts over and 1 gets added to the left side. Okay, so 1 is already present, so it will become 20. Now same here with the binary. We cannot exceed 2 here, or 2 digits, 0 and 1. Now if we want to go to the next number, what we will do here is we start over and we add 1 on the left side. Now see here, we're adding 1 on the left side. The series starts over 0, 0, and the 1 gets added. This is the pattern. Okay, same goes with the octal. Notice here 0, 1, 2, 3 up to 7, and then we start over from 0, 1, 2, and this one gets added. Okay, here see 7 we cannot have 8. I mean, in decimal we can have 18, but in octal we cannot have 8 here. So we start over from 0 and 1 gets added on the left side. Okay, there was already 1 present here, so it becomes 2. Okay, when we reach like 77, and we reset this both series. Okay, 0, 0 and 1 gets added. Same here, same case here with the hexadecimal. We go up to F, and then we start over from 0. Okay, this is the pattern we should follow. Now, if we are printing counting, let's say we are printing counting from 1 to 100, this is the basic algorithm. Okay, now notice that here we are printing in binary, octal, or hexadecimal. Now, this is the basic algorithm how we can write counting in different base numbers. Okay, the counter here is 0. It started from 0, and we have loop here. It is converting a simple number into a binary, octal, or hexadecimal. Now this algorithm looks pretty simple, but notice that here this main algo is missing. Okay, this is the main algo which is missing from this algorithm. So before moving on, do you have any questions about uh, any base numbers? Or shall I continue?
Sorry, the algorithm, yes, this one algorithm in this one, these are the codes which we need to write in order to get the conclusion.
Yes, in real life, we would have to write the code, but in initial stages, we write algorithms. The algorithms are like simple language. We write it in simple language.
Yeah, algorithm and pseudocode. Is this the pseudocode as well?
Pseudocode is a type of algorithm.
Okay. So if we
Algorithm.
are like
Okay, okay.
yes, sir.
Sorry. Continue.
No, no, you can continue.
I'm
I was
saying
just confused between I was just confused between algorithm and pseudocode. That what if we are asked to write the pseudocode? Can we write this thing?
yes. Uh,
Okay.
Algorithm is like a big class of like different types of algorithms. There could be different types of algorithms. Pseudocode is one type of algorithm.
Okay. And sir, just now you were showing us about C++, right? Even you were writing these things over there as well. So
See,
can we do this for other languages as well, or there is some other codes that we need to memorize?
well, there is a little basic difference of some syntax, how the language works, and how to write a language. Well, the concepts are pretty much same.
Okay, sir. Thank you.
Okay, let's see the conversions. Now, let's see the conversion from decimal to binary. Now, same here, we should always see the patterns. As beginner, let's see this column, okay? Division by 2. Okay, any number given, we can convert it into binary by dividing it by 2. Okay, we keep dividing it until we get 0 in quotient. Okay, I don't think I have to explain the division method here. You guys are pretty familiar with the division, how division works. So we just divided 13 by 2, okay, and we get the quotient 6 here, and reminders are very important here because these will be included in the final answer. Okay, the quotient is 6 here. If we divide 13 by 2, the quotient is 6 and the reminder is 1. Okay, the same, we get quotient here. Now we are dividing the quotient by 2 again. See the pattern? We divide a number and we get quotient, and we again divide the quotient by the base number 2. Okay, we get the quotient again, we get a remainder, and so on up till we get 0. So the reminders here, see that this arrow, this is going from down to up. Okay, why I drawn this arrow? Because we have to write the answer from down to up. We cannot say 1 0 1 1 is the answer. No, that would be wrong. We have to go from bottom to top. Okay, this on the answer here, see the convariant answer here is 1, then again 1, then 0, then 1. Okay, here is how you can do it on the paper. Let's say we are converting 17 here. We draw these lines and write 17 here to here. The quotient become here, and the reminders, we keep record of reminders here. Okay, we keep dividing it until we get 1 or 0 here. Now if we are stopping at 1, we have to include that in the answer. But if we're stopping at 0, we don't have to include this 0 in the answer, because if we do include this 0, this will get like will be left out of the answer, because it is the leading 0, and leading 0 does not have any effect on the final answer. So we will leave this. Okay, and after we are done with the division, we start writing from bottom to top. Okay, did you guys get it?
Yes,
Yes,
sir.
sir.
If I were to give you a number to convert, would you be able to convert it?
Yes, sir.
Yes, inshallah.
Here we have 17. Try converting it. Try converting 16 into binary. I'm gonna give you like I don't know, 2 minutes or 3. Let's see how fast we can do. We have you guys have pencil and some paper near you, right?
Yes, sir, I'm working upon it.
Okay. Just let me know when you're done, so we don't waste a lot of time.
For 16, right?
Yes, yes. Or you can
I am
convert
done.
any number. What's the answer?
1 0 0 0 0 4 times 0.
Okay. Has anyone done it?
I'm getting an 11 1 0 0 0. It's like 4 zeros
Uh,
for 16.
yes. Keep dividing 16 by 2. Okay. And quotient. I think you guys are getting different answers here.
Yes, sir.
All the binary is 1 and then like 4 zeros. Has anyone got their answer?
Oh, sorry, sir. It's actually 1 and 4 zeros.
Yes.
I found my error.
Okay.
Sorry.
See, the practice makes us good at solving problems.
Yes.
Now, by this method, you can convert decimal into literally any base. Okay, if we have like any number here, and we keep dividing it by 8, so the final answer will be in octal. And if we have a number, we keep dividing it by 16, the final answer will be in hexadecimal. You got the point?
Yes, sir.
Yes, sir.
Any confusion in the conversion?
No, sir.
See here, we have this number and we're dividing it by 16, and the quotients, we're receiving the quotients and the reminders. Now see here, the main difference, 15 corresponds to F. Okay, we saw that in the previous slide that 10 becomes A in hexadecimal, and 11 becomes B, and so on up to F. We do not have a 16 in hexadecimal, so the 15 we go up to F. Anything bigger than that, that would be out of the scope of the base. Okay.
Yes, sir.
Yes, sir.
Shall we do an example of hexadecimal, or shall we continue?
Let's do an example.
Okay, let's convert. Here we have 35,000. Let's convert 30,000. Just let me know as soon as you're done. You can use calculator for the division. Anyone?
No, sir. Can you do this with us, please?
Okay.
Yes, actually, I don't know how to convert it to hexadecimal.
And it's simple. Just keep dividing the number in 16 until we get a quotient 0 here, and we keep the record of reminder just like binary.
Okay.
You guys didn't understand the binary?
No,
No,
sir.
binary is
Binary.
clear, sir.
Yeah.
Binary is clear. Okay. You see, we get the problem here because the number gets too big. Let me find an smaller example for you guys. Okay, I thought
Yes.
maybe you would be able to do it. How about converting 100? Try
Okay, sir.
converting 100 into hexadecimal.
Sir, what I'm getting is if I'm dividing 16 by 100, then I'm getting 6 and 4 as the remainder.
Yes, sir.
Yes,
64.
exactly. That's the answer. Okay, you guys got it.
So how
I
would we
thought,
write it then?
yes, that's right. I just gave you a bigger number because I thought you guys were using calculator or something. You're doing it on calculator or just doing it in head?
Over a paper.
Nee, the
Yes, we are
calculations.
making use of calculator for
Yes, yes. Okay,
divisions.
okay, okay. Okay. So shall we move on?
Yes, sir.
Let's see its
Yes, sir.
algorithm. Okay. We saw an example of binary and hexadecimal. So I wrote the algorithm for base 8. Well, if we just change this algorithm a little bit, I also have left this hint for you guys. We can convert it into any uh, conversion. Like we can use this algorithm to convert from decimal to binary or decimal to hexadecimal or octal. See here, first of all, we need a variable in which we store the base. See, we were getting some result. Okay, we need to store that result somewhere. So we need an array for that because we're not getting the reminder, all of the reminders at once. So we need an array for that. So we could just keep appending in the array the result we're getting. Okay. Then we're just prompting to the user to enter a decimal number and then enter decimal number, whatever user enter, we store it into another variable called number. We have a quotient. See, the quotient is required to uh, store the result of division, whatever is remaining. So to divide it again with the base number. So here we saw the pattern and we can implement it inside the loop. See, the thing is like repeating itself. Okay, the quotient get divided again and again by the base number, and we are receiving the remainder. Okay, uh, the condition would be the ending condition of the loop would be like either the quotient is 0 or 1. So we are just checking it with the 0 here. Okay, and here we are storing the results into result array. Okay, see the counter here. Okay, we cannot just keep appending the array. We need to tell the array at which point it should store the result. We can get the division by this in the C, but notice that here we have quotient and this percentage sign here. Okay, this is not percentage in computer language. This is a modulus operator. What it gives you the reminder. Okay, see, we are getting this reminder here. Okay, uh, if we divide this number by 16, here we are dividing this in computer. If we write this statement, we will get this quotient. But if we write a modulus here, we would get this remainder. So that's what we are doing here. Okay, and this is like the whole logic inside the loop. And then we're ending the loop and printing the result. Uh, Notice that we printed, we wrote the result in reverse. Okay, from A, B, 2, and F. So here we have to print the array in reverse. That's why I wrote this line, print array in reverse. Now this would work fine with 2 and 8, but if we were converting to hexadecimal, we would need this logic. Okay, now I have left error here potentially. Can you guys spot it, the error in this? Now let me explain that first. Okay, this logic. Let me explain this logic. What it is doing is it is checking that if the array value like this 10, if this is 10, we should print A. Let's go back. See here, the remainder is bigger than 10, so we should convert it into corresponding letter. Okay,
Yes, sir.
that's what we're doing here. We are checking that if the value stored in the array is if it is 10, it is we should print A. If it is 11, we should print B. If it is and so on. Okay, now in this algorithm there is a little error. Can you guys spot it? Anyone? Or should I tell you guys?
Trying to look for it, sir.
Okay. Okay, if no one has got
Is it
it,
to something?
yes, yes,
Is
please.
it something to do with mentioning the quotient?
No, it is just printing the result.
Oh,
The
okay.
double equal signs.
No, that are fine. These are fine. It okay.
Should
Let
we
me tell
add
you
something
that.
in this one?
What?
Have to add something in this one, or we should remove something?
Okay. Here we should remove.
Okay, just a moment. Just a moment. What about and if? No, start something this.
What? Can you repeat yourself?
Should we have to remove and if or start if? Multiple times it's coming.
Yeah, that could be an optimization error. I mean, we can fix that. We should remove
All
that with
right, give up.
if else if. We can
Yes.
use
All right,
if
I
else
give
if.
up.
Okay. Here, see that we are still printing this. Uh,
Yes. Oh, yes, yes, yes.
okay,
In the last,
like it converts it into A, but still it will print the value. Okay. Now we have
All
to
right,
remove
got it, got
that.
it.
We have to remove that, and we should check if the value is greater than 10. Then we should implement this logic. Otherwise, we should just print here. Here is like one. Okay, we have to remove this, or either we can do put an other if else here. Okay, if value is greater than 10, we should execute this. Otherwise, we should right away print this. Got it?
Yes, sir. Got it.
I got it.
Okay. Let's see its code. Okay. Here we have the same thing in, we just added syntax here and a little bit more, few more steps. You will see that the algorithm and the code is like, uh, it's basically converting algorithm into code. Okay, just applying the syntax of the language and we will get the code. Uh, Here we have base. Here we're storing 8 in it, or we can store any base like 2 or 16. And then we have this, we are declaring these variables. See, we need this reminder, quotient, and we need a decimal number. Okay, where it will be inputted by user. Okay, we are get, we're declaring an octal number array here, and then we are setting the counters here. Okay, in computer language, it is like common practice to use this I, J, K, and so on for the loop counter variables. Okay, as programmers, we should also follow the tradition or whatever you can say it is. It is just a common practice to use for variables. We use the letter number that comes in ABC. For constants, we use A, B, C, and so on. And for variables, we use I, J, K, and so on up to X, Y, Z, and so on. Okay, X, Y, Z up to X, Y, Z. Then we are asking the user for the number, and we are storing that number into a defined variable. Okay, the quotient would be at the start of the program would be equal to the same number. Then we're starting the while loop and checking if the quotient has become 0 yet or not. And this is the logic of the loop that we saw in the algorithm. Shall I explain it again, or did you guys get it from the algorithm?
Sir, on number 8, it's written scan F. When do we use this and that percentage
Scanf.
sign? Yes, one.
Okay, this printf, we use it to prompt user on the console something. Wherever we write in this the double quotation marks here, it will get printed on the console screen. Remember that we saw that on the C compiler online, where I wrote the value of equation and counter. I wrote them in printf. Okay. If we want
Yes,
to
sir.
take input from user from console, okay, then we use this scanf. This is indication to the language that we are expecting a integer from the user. Okay, modulus d. If we were expecting a string, we would write modulus s here. This is the
So,
like
sir,
the syntax.
do we have like any reference sheet or anything in which we can refer? Because obviously, since it's new, we wouldn't know which one is for modulus and which one is for string. So, do we have anything as such from which we can refer?
Okay, I will give you some resource links where you can learn the C language syntax. But I'm pretty sure if you follow along, you will be clear. Look here, this is a modulus, okay? But if we are using it inside scanf or printf, it is indication that the next digit, the next alphabet is what we are expecting. So you see D here, it is short for decimal or integer, decimal. Okay, so we are expecting an integer type here. Okay, let me put
Okay, sir.
Okay. Here, see, we are printing the array in reverse. In algorithm, we just wrote that print array in reverse, but in any language, we cannot do that. Okay, we have to uh, write it in reverse. Okay, this is the result array in which we were storing our remainders. So I started from, you see, I used the counters here. Okay, this counter variable was equal to the length of this array. Okay, so I initialized
Yes.
another counter with the same length. So I kept decrementing it until it goes up to 0. So that's how we print in reverse. So shall we continue, or you have any more questions in this?
Sir, in number 8, scanf, the modulus, and then there is one more mark, I guess ID, right?
Uh,
But whereas in the 17th one, G, this one, yes, 8 ones,
yeah.
and in the 17th, yes, printf, modulus D. So where is I?
Well, this is not I, this is L. In C, we
Okay.
have like integer and double, and then we have long double. Now I might have left it and not planned. It was not planned to leave it here. I was testing the code. If you include some libraries here and copy paste it, this will run fine. I was testing it, so I might have left it without knowing. Actually, it is a long double. It is also a type in C, so it stores larger numbers that cannot be stored into integers. That's why it is here. If you run it with D here, it will work just fine.
All right. Thank you, sir.
See here,
And
it's
sir,
also
basically this
lengthy.
whole algorithm, okay, this whole code is of C++, right?
No, in C,
In C, okay.
these are two different languages: C, C++, and then we have C hash or C basic, known as C basic. There are like three different languages. So as a beginner, I mixed them up a lot, but this is C.
Okay, sir. Thank you.
As a beginner, we can like mix them up sometimes. So don't worry.
Okay, sir.
Now let's see the conversion from other bases to decimal. Okay, we saw from decimal to other bases. Here we have binary to decimal. Okay, if we were able to go to other bases, then we should be also be able to come back into decimal. Okay. Do you guys remember how we converted into binary, the pattern?
Yes, sir.
Yes, sir.
Can you please explain it a little?
Yes. The division method, right?
Divide
In
Yes,
by
every set
12,
of
or it was by 8, I guess.
yes. We divided it by 2 if we are going into binary, and 8 if we are going to octal, 16, and if we are going
Yes.
to hexadecimal. Now, if we are going back, what's the opposite of division?
Multiplication.
Yes, of
multiplication.
course. Here we will multiply by 2, but notice that here is a power. What is this power doing here? Okay, this is the formula to convert. Okay, we write this bit. See here, binary number is written in different columns, and then we have a power of 2. Well, we can remember the formula for this one, 2 is power n minus 1, but we don't need to remember that. Okay, we can just keep writing this 1, and then we multiply it by 2, keep writing 2, and then from the right side we start from 0 and we keep writing 1, 2, 3, 4, 5, and up to the last number. Okay, wherever the last number comes, we stop. Okay, here in this case we have 5, so we start from 0, 1, 2, 3, 4, and we stopped at 5. Now the length of this is 6, but as we're starting from 0, so we stop at 5. You guys got this pattern?
Yes, sir.
Okay, great.
Yes, sir.
Now see that we are also adding the final numbers of this. So the
Yes, sir.
answer would be 57. Uh, do you guys remember which number we converted earlier? 16, I guess.
Yes, sir. It was
Yes, sir.
16.
Yes. What was the answer?
1 and 4 zeros.
Okay. Can you try this method on the answer?
All right.
Yes.
Yes, sir. I'm done. It's giving 16.
Okay. The basic purpose was to just make this method go through your hand and get a little practice out of it. Everybody done?
Yes, sir.
Okay. Now,
Sir.
if we
Yes.
are okay, if we are converting it into, let's say we're converting an octal to decimal, what would change here? Can anyone tell?
Yes, 2 will become 8.
Okay, excellent. And if we are converting it into hexadecimal, what would change here?
16.
Okay,
16.
now you guys got it perfectly. Mm. Well, we also have a shorter method. I don't recommend using it right away, but if we are like testing a program or doing some coding, we can double check our answer using this. Okay. Here we have some lines written. Divide each bit in a column. That's what we did here. Let's say we have a binary like 1, 1, 1, 1, 1, all the ones. Okay. Uh, we divide it into columns. Okay. Just like in the previous example here, we have different columns and we have written each value in each column. So here we have done that. And under that, start writing from 1 and then 2 to the power um, n. Okay, under each column. See 1, 2, and here 2 to the power 2 is 4, and 2 to the power 3 is 8, and 2 to the power 4 is 16, and so on. No matter how long this bit is, the sequence of a binary is, we can keep writing. What comes next? 62. Okay. Did you guys got the formula?
Yes, sir.
Sir. Yes,
Okay.
sir.
And the final step here is see whichever bit is 1. Okay. Add the number in the next row. Okay, if this is 1, we take 32, we write 32, and then if this is 1, we write plus 16 here. If this is also 1, we write 8 here. Let's just say if this was 0, we would skip this 8, we would not write this 8 here. Okay. And if this is 1, in this case it is, and if it was 0, if we could skip that, but in this case we're gonna write 4 also. So when we end up adding these numbers, we would get a number in decimal. You guys got it?
Yes.
Can you convert the same number using this method?
Okay, sir.
The answer is pretty obvious.
Yes, because
Yes.
I'll just speak after Azan gets over.
Yes, sir. Understood.
Okay. We should not use this in programming logic. I mean, we can use it, but at this level, I would recommend using this method. Okay. But for double checking your answer, you can do it like this. Now we have hexadecimal to decimal. We saw that how we can convert. Uh, it's like same. Okay. Here I asked you if we want to convert it into hexadecimal. You guys answered correctly that we would have to change it with 16. Now the whole other logic remains the same. See here, the 0, 1, 2, 3, the power 0, 1, 2, 3. That is same. We are multiplying it with the base, and we are separating the number. We're just converting this e into 14 that we already know. A is 10, B is 11, and so on. We already know that. So this is the algorithm for converting back to decimal. Now here we have a string of binary, and we have a base 2. Uh, we, uh, we also have a result here as well. Uh, Here see the power of base. This, it is starting from 0. So we are initializing it with 0. And in the loop, we are incrementing it using increment operator. See that plus plus sign.
Yes, sir.
Okay. Well, this algorithm is kind of a reverse of the algorithm we saw earlier for the conversion into other numbers. Here we are multiplying it, and we are incrementing this value base, power of base, and we are adding the result here. Okay, this if else here is just to check if a digit is allowed in the base or not. Let's just say if it is a base 2, so number would be less than 2. If we have like here 2 and base is also 2, this would like go into else part. It will not convert it. Okay, as programmers we should also handle errors in our programs. If we don't put it here, if I have 2 here, so it would still convert it. Okay, of course the answer would be wrong, but the program will not stop and it will continue working. So in else, what I'm doing here is just setting the result equal to -1, and I am breaking the loop. You guys learn that break and continue in previous lectures, right?
No, sir.
No, I think I saw your slides. There was topic. Okay, let's say that we are in a loop, and loop only ends when the condition is met. And if we want to break loop anywhere, like if the condition is met or not, we write this break keyword. Okay, so it will just break out of the loop.
Okay, sir.
Did you get it?
Yes.
Okay, here is the code. Uh, shall I explain it, or did you guys got the algorithm? Now notice that here,
Got it.
just one more thing. If we want to change this algorithm into octal, we would change this base, okay, into 8 or 16. But in 16, we also have missing the algorithm we saw earlier. Remember, there was a pop-up where we found the errors. That piece is missing here. Okay, I also have that piece included. If you want, I can show you in working. I have written the code here. Let's go into code blocks. Are you guys gonna use these code blocks, or we should keep using the online editor?
This one is much better.
Online one or
Yes.
the one? Okay. Yeah, it's easy.
we use code blocks, do we have to like download it?
Yes, this is a program that allows you to write C language. So it's open source, lightweight. If you don't want to download it, you can keep using the online one. It's easy, and we do not need the installation of it. But here's one problem. Like if I refresh this page, the all of my work will be lost. It's not saving. That's why you see I have created another file here in which I have stored this code. Okay, let's hope we do not get any errors. So if I am converting a binary here, oh sorry. Okay, let's say I'm trying to convert binary here, which cannot contain zero. So sorry, which cannot contain two. So I have to give the base of this number. I have to provide the base, the which base I am converting it into decimal. So this is 9. Can you guys recheck it that it is actually 9? Can you guys reconfirm that using the shorter method?
Yes, sir, just doing it. Yes, sir, it's 9.
Okay. Now, if we run this again and notice here, as I said, 2 cannot come in binary. As you can see, all the others are in binary, but this one is not in the binary. And here we also give base 2 that this number is of base 2. So the answer is like not accurate. Okay, I have condition I might have, okay, greater than or equal to here. Condition was of one value. So it did not. In testing, we will see how we can find on which values we should test. Okay, 2 and 5 does not come in binary, so it returns me -1. Okay, now if you run the code provided in slides, that we were fine with binary and octal, but it would not work with hexadecimal. I have left that intentionally because if I would provide everything, you would just copy paste and don't do in practice. So I would recommend trying it yourself. And if you're not getting anything, then you could come to the slides and take help from it. Okay. Now this input part, I have this input part done here, but it is not included in the slides. Well, this is pretty basic and I'm pretty sure you guys will figure it out how to do it. If you guys don't know the language yet, I will provide some reference material also for you guys to practice and code in C. So shall I continue or shall I again explain any of this thing?
So just continue.
Okay. Uh, Here we have a binary arithmetic operations. Uh, we would see addition in binary, how we can add two binary numbers, how we can subtract two binary numbers, multiplication and division. Okay, for that I have notes. Okay, is this visible?
Yes, sir.
Okay. Now in binary, see here, 0 plus 0 is 0. 1 plus 0 is 1. But what is 1 plus 1? Well, in decimal, it is
1.
no. In if we're adding this in decimal, it is 2. But 2 we cannot write in binary. Uh, remember that when we exceed the pattern, that 0 1 pattern, or in decimal, when we exceeded the 0 1 2 up to 9, and what happened next? We add 1 to the left and put 0, so it would become 1 0.
Yes, sir.
Okay, we cannot write 1 0 here. In decimal addition, what we do, we carry the number. In binary, we do the same. Okay, 1 plus 1 is 1 0, so 1 gets carried here. See that I have left this carry to make you guys understand that this is a carry column. So here we have 0 0, so this 1 plus 0 plus 0 is what? 1. Now again here, see that we have two ones, so we just solve that. It would become 1 0, so 1 would get carried. Now here we have three ones. Now how we are going to solve that? Here, see that a hint, uh, three ones, we divide, we use here divide and conquer rule here. We first add two numbers, and that we know that that would give us 1 0. Yeah, this is 1 0, and we have that one left. Okay, so we just add these two, so it would give us what? Two ones. So we can write 1 and 1. So that is our answer of addition of these two binary numbers. Any confusion in binary addition?
So
Okay, let's move on to binary subtraction. Mm, In binary subtraction, we have 1 minus 1 is 0. Okay, and 1 minus 0 is 1. Well, 0, if we subtract 0 from anything, the same number comes. So same apply here. We get 0, and if we subtract this from this, we would get 1. But notice that we cannot subtract anything from 0. So we have to carry this one here. Now, when we carry this 1, this will become 1 0. See, 1 comes carry, and 0 is already there, so it becomes 1 0. And we can write this 1 0 as two ones. See here, 1 0 can be written as two ones. Okay, addition of these two will give us what? 1 0. So we would get two ones. So if we subtract this 1 into 1, we get 0, but this 1 remains here. It will not get cancelled out, so it would come down here. Okay, that's our carry. So let's go back. So the answer here is 1. Now remember that we carried from this one, so here we have only 0 left. What we can do here, we can again get carry here, and this will become 1 0, and we subtract that, we get the same result here. We would get 1. Now this is also 0. So 0 minus 0,
0.
0. Okay. Okay, 0 and 0. So we can neglect these, as these are the leading zeros, and leading zeros don't have any effect on the original value. So this is our answer. Any confusion in the carrying part?
No, sir.
No, sir.
Yes, sir. I would like you to explain it again. please.
Okay. See here, we cannot subtract anything from 0. Okay, in decimal, what we do, we take carry from the next number. Same in the binary, we carry this one. This one was carried, okay, from here. This would get cancelled out and it becomes 0. Okay, now here it becomes 1 0. When this one gets attached with this 0, it would become 1 0. Okay, you're getting that point?
Okay.
Okay, so 1 0 is equivalent to 2 ones. Or you can simply say that when we carry in base 2, it becomes 2 ones. That's the shorter method to remember that. But if we see that logically, that's what's happening. So this one gets cancelled out with this one. So this one remains untouched. So it will come down as it is.
Okay, sir, understood.
Okay, great. Here we have binary multiplication. Well, this is also simple. See here, any number multiplied by 1 gives the same number. Now, in decimal, we have this pattern. We put cross and then multiply it with next digit. So we're going to follow the same pattern. So if I multiply this one with all of these digits, it will give me the same number. 0 here and 1 here. Now the next number is also 1. Okay, we are multiplying this one with all of the binary numbers. So we get 0, 1, 0, and 1. Now next is 0. What would be the answer multiplying with 0? All of the zeros up. Okay. Again, we have the same number as we are multiplying it with 1. Now here, I want you guys to do the addition. Just keep telling me the number what would come here and I would keep writing. Anyone?
0.
Okay, 0.
1.
1.
1.
1.
Even here, I guess 1.
Okay.
No idea about this one. Is it?
It's going to be 0, right? It's going to be 0.
Okay.
And 1 will be get carried over there on the next column.
Okay. That is the correct answer. I mean, if you had any confusion in addition, why didn't you ask me then? Okay. In binary addition, we cannot have 2 here. Okay. 2 cannot come in base 2. So 1 plus 1 is 1, 0. Okay, remember that pattern we discussed earlier at the very beginning when we were seeing the basis. Okay, that pattern. Okay, it becomes 1, 0. So we do not have place for this 1 here. So we put 0 and the 1 will get carried here. Okay,
Yes,
so here we have 1 and 1.
1 and 1.
Okay, that
Yes,
is our
understood.
answer. The division, it also works same as the division in decimal. So we check the number that if it is, it can be dividend or not. So if it is not, we put 0 here, and if